Hello again, welcome back to the shop. Today going to be doing some more work on the Galloway hit and miss engine. I have the casting here. This is going to be the casting for the water jacket, and what I'm going to do first is I'm going to machine this surface. This will be my reference surface for the rest of the machining. So I got to get this mounted up in the mill and get it leveled up the best I can, and then we're going to machine this surface. And according to the blueprint, there's 4 holes that need to get drilled and tapped in this for the water hopper. The water hopper is going to mount on top of this. So let's get this set up in the mill and get started on it. Okay, I think I got this dialed in pretty good. And the X and the Y were 0.003 difference there. And if I bring this across this way, we're about 0.004 difference that direction. Roughly. So I'm going to get an end mill and put in here, and I'm going to machine this surface right here. Okay, I'm going to raise this table up till it just touches. Dial here. All right. I'm going to raise the table up 0.020. I want to machine this till it just cleans up. I'm going to come up another 20. They don't tell you how much to machine off of this surface, but it looks like, according to the blueprint, to make it look like the print itself, I got to machine about another 100 thousandths off of this. So I'm going to raise the table 50, and we're gonna cut it again, and I'm going to look at it. Okay, I think I got this all machined off here. I cleaned up the surface and was looking at it. It just didn't look right. So I measured, the drawing is in half scale, and they didn't specify a measurement for this height right here to the actual water jacket. So I measured it on the drawing, the picture on the drawing with a caliper, and it showed it was about 100 thousandths, and it's half scale. So this one here should be about 200 thousandths. Let's measure it here, see where it's at. I got 210. And I looked at some pictures online that I found of these motors, and it looks like that's about right. So that's what I'm going to go by. Now what I have to do is I have to get this water jacket mounted on an angle plate so I can machine the ends for the overall length. Okay, I got this water jacket clamped up on an angle plate here. According to the drawing, from this leading top surface of the water hopper to the front of the cylinder, it needs to be 375 thousandths. And I measured it now, and it's roughly 575, so I got about 200 thousandths that I got to remove off this surface. So I'm going to get most of it with an end mill, and then I'm going to go over it with a fly cutter to make sure it's completely flat. This surface right here is the surface where the cylinder head is going to bolt to. We got 520. So I'm going to take another 100 and then I'll measure it again and I'll be back. Okay, I made a pass here with the fly cutter, and I've got about 4.5 thousandths to go. I'm just going to take 5. Raise the table up 5 thousandths. And we'll cut it. The overall length of this needs to be 4 inch, 469 thousandths. Well, I got this side all machined. Now I'm going to grab a depth mic and I'm going to check it, see how it did. Turn it till I just feel it touch. We're at about 469.5. So that's good. Now what I got to do is I got to bore this internal hole there at the bottom there, and this surface right here, that smaller hole gets bored to 2 inch 225, and the outer one gets bored to 2 inch 260 for the sleeve, and then it gets bored all the way through to the front. The sleeve is actually going to be a shrink fit in this here. And it's got to be this surface down here from the top here to where I have to finish boring is going to be 2 inch 719 thousandths deep down to that hole there. All right, I got the boring head set on the mill and I got the depth set. And I made a cut down inside that hole there. I don't know if you're going to be able to see it or not. Possibly. light here where you can see. I got to bore that portion of this, the sleeve, or the water cylinder, the water jacket, I guess you call it, out to 2-inch 225, and then the upper portion gets bored out to 2-inch 260. But I'm not going to film this inner portion here. There's nothing really you're going to be able to see. So I'll come back when I get ready to bore this here. Okay, I got the inner bore done, and I'm working on the outer one here. This should be the last cut on here. So bring this down here. This bore was at 2-inch 255, and it's got to be 2-inch 260. Snap gauge here, and I'll measure it. Well, according to that, I'm 2 thou under. Take another measurement here. Yeah. 2 thousandths under. I'm going to advance this boring head another thou. It really doesn't matter if this size is exactly right on, because the sleeve I gotta make the sleeve yet, and they want the sleeve to have a 1.5 thousandths shrink fit. So whatever the idea of this is, I'll just make the OD on the sleeve accordingly. But I want to get it as close as possible. Take another measurement on this here. Looks like I'm a half thou under. Measure this one more time here. Yeah, about maybe just about a half thousandths undersize. That'll be good. So this part is basically done. Okay, there's the inner bore right there. And the outer bore here, and the sleeve is going to get a shrink fit into this, and then the whole thing will get bored to 1 3/4 inches. But what I have to do, this is for the drain for the water jacket. I need to drill and tap, I'm not exactly sure what size, and then there needs to be in the back side of this here, at the bottom of this here, there needs to be a hole that intersects with that drain hole, and that's so you can drain the water out of it. So I've got that to do yet, and make the sleeve. So okay, I got this piece of Durabar chucked up. And the first thing I got to do is I got to trim it to length. It's about 150 thousandths long. It's got to be 4" 50, 4" 500 total length. Covered up to help kind of contain the mess. See how this went here. Half a thou under, thereabouts. So that's good. Okay, now what I got to do is I got to turn the OD of this for the steps in the cylinder of the water jacket. The first diameter I got to turn 1.5 inches back to 2.275. So I got to come back. It's got to be 1 inch 750 long. this here. See what size it is. It is 2-inch, 655 and a half. 2.6555 right there. It's 2-inch, 655 and a half right now. I got to turn this down to 2-inch, 275. Set my dial to 0. I'm just going to dial in 40. Okay, getting down to it here. I got it's at 2-inch 300 right now. It's got to be at 2-inch 275. So I'm going to take 12 thousandths here. And make a cut. I'm going to measure it and do the rest on the final pass. Here, grab a micrometer here. And we got 13.5 thousandths to go. measurement here. I'm at 276 and a half. It's got to be 275. $275 and maybe a tenth. So when we get that engine frame, we'll see if it fits. Yep, perfect. Okay. We'll get it back off here. There we go. I'm going to break this back edge here a little bit, and I'm going to flip it around to do the other two surfaces. Okay, this part here has got to have some steps in it. So the first portion has got to be 2-inch 261. It's going to be a band 1/2 inch wide, and then it's got to get stepped down to 2-inch 250, and this is going to be the final diameter for fitting it inside the water jacket. All right, I have this portion turned down to 2" 280. It's pretty hot at the moment, so I'm gonna let this cool down and I'll be back. Okay, this had a chance to cool off now, so I'm gonna make another cut on this here. Check it here a minute here. It took 15 thousandths off. It was at 2.283. And I took 15, and I'm at there's 60, 65. We're at 267 and a half. And I want to be 2.261. We're at 262 and 3/10. Cut back a little further and I'll measure it again. $261 and 4/10. So I'm 4/10 over. Okay, I marked it here with the tool. I got to turn back to that line right there to 2" 250. Yep, that's good. Okay. Now I got to turn back a 1/2 inch to 2 inch 230. So I'm going to take 10 here. I'm going to measure it. That again needs to be a 1/2 inch wide. Okay. We're at 2 inch 240. I think. Yeah, that's 30, 35, 40. Yeah. Okay, we're at 233. I'm going to take another 2. About a 1/2 thou up. I'm going to polish that a little bit, and and we should be good. Let me get a piece of emery. Looks like we're right on it. So I'm going to chamfer this leading edge here a little bit. That'll give me a little bit of a lead in, and this is ready to be pressed into the water jacket. Okay, I'm going to throw this part in the freezer for a couple hours and I'll be back. Alright, making some progress on this cylinder here. You can see the sleeve where it's pressed in the water jacket. I didn't film that because the camera went dead, and I got a hole through it and made a couple passes with the boring bar here. It's at 1 inch 415 right now, and I got to take it out to 1 inch 750. And due to the stick out on this bar, because this cylinder from the chuck to the face is 6 1/4 long, if I try running it real fast, I get some chatter. So I'm running it at 140 RPM, taking about 6 thousandths feed per rev, and I'm taking 25 thousandths a pass. And once I get up to 1 inch 600, I'm going to grab a bore gauge and go down with the dial bore gauge, and I want to see how much taper it has. So let's make a run through this here, and then I'll bring it back when I'm closer. Well, I'm getting ready to do my final cut here, and I ran into a bit of a problem. Right down in the bore right there, I don't know if you can see that, there's a hole. I don't really know how far up the piston's gonna come. It's got a 3.5 inch stroke, so I don't know, but that's, I don't know if you can see it or not, possibly. I don't know how I'd fix it. The only way I could think of fix it would be to bore this out to like 2 inches and make a sleeve, press it in to get rid of that bad area, and then rebore it. You can probably see it right there. It's right where my screwdriver tip is. There's a bunch of holes there. I don't know. I'm gonna have to think about it and see. So I'll be back. Okay, here's my plan. I bored this out to 2-inch, and as you can see, there's still a little tiny spot there right at the tip of this scale here. There's still a few little tiny little spots. So I bored it out to 2-inch, and I'm gonna make a sleeve and press it in, and then bore it to size, and then hone the whole business. That's my plan. So when I get that piece ready to press in, I'll be back. Alright, I got this piece over in the press here, and I got some Loctite sleeve retainer compound. Get some of this put on here. That there. I'll go get our sleeve out of the freezer here a second. I'll be right back. Here's our repair sleeve. Get some of this sleeve retainer put on there. Like that there. Just set on top of here. I put a little lead in the top of it, so it should start easier. A little block of aluminum here. And we're there. All right. I gave it a 1/1000 press fit, so it should be good. All right, I'm gonna get this set up in the mill and get this bored out, or not in the mill, in the lathe. All right, I think our repair here was a success. You can just barely make out the edge of the sleeve right here, barely. I got 2.5 thousandths to hone out of it. So I'm going to face the front, and then I'm going to pull this part out, and I'm going to go over to the sun and hone, and I'm going to hone it. All right, let's get the front of this faced off here. All right, beautiful. Got a little bit of taper in it, so I'm just checking it here. That's why I'm honing it on the front more than the other places. Yeah, we got a long ways to go. Well, let's have a measure of this thing once here. We're at 0 right there. Right there. Zero right there. I don't know if you'll be able to see that all the way at the top, but it's 0 there. Let me flip this part over. Put this back in there again. Right there, you'll be able to see it. It's 0 right at the top of the bore. So pretty good result for what it was. There's the inside of it there. You can just barely make out that line where that sleeve ended. So and it's got a little mark at the top here. You can just barely make it out here at the top. So I'm pretty pleased with that. Well, I'd say that was a pretty good result for a disaster. I didn't really know any other way to fix it other than to sleeve it. The spot where it was right at, as the piston was coming up the top dead center, right where the rings would be, and I knew it would be a problem down the road. So half a day's worth of work for a porous casting, but that's how it goes sometimes. So anyway, now we can move forward with this. Grab this engine frame out here. This is going to slide on the top here like this here, just like that. And your water hopper is going to mount on top of here. So I believe the next part is going to be probably doing the crankshaft main bearings and doing the crankshaft itself. I need to see about that yet, but anyway, I hope you enjoyed that, and we made success out of a disaster. So have a great day. We'll see you in the next one. Take care. Bye-bye.